All right. Hi, everybody. Thanks for coming to the session. I'm Aaron Parecki, Senior Security Architect at Okta. And as Mike said, I'm also involved in the OAuth working group where I help write and contribute to the specs and maintain the website oauth.net, which is the community home of OAuth. So I am just steeped in this world all day, and it's a lot of fun to talk about. So the plan for this session is I'm going to share an update about sort of where things are in the OAuth world and talk about a little bit of background so we have some context, but then talk about the best current way to do things in OAuth, as well as talk about some of what's happening in the future and what you can expect to see coming up in the in that world. So before we get into OAuth itself, I want to set up some of the context around why we actually have OAuth. And this really came from the past, where we were very used to the idea of password-based authentication. And that would be something like you would enter a username and password into an application, and then it would send it over to the API, and the API would validate the password by probably looking it up in a database, for example. And then it would return data, or you would be logged in. And this, of course, has a number of problems, because especially if you're storing passwords in plain text, which thankfully is not something that is very common anymore. And instead, what is a lot more common is storing, instead of the password itself, storing a hash of the password. And this solves the problem on one end of not where it's not a good idea to store passwords in plain text. However, this doesn't actually solve the problem on the other end. That problem being users are still entering passwords into applications. So you may see screens like this as you're using your various apps on your phone. And this is a pretty common thing. And for a simple application that maybe has just one native app and talking to one API, this probably does actually work fine. However, you start to very quickly run into limitations with this. For example, when you want to add multi-factor authentication, because now all of a sudden you're building in multi-factor auth into your app. And there's of course many ways to do that. And that could be anything from SMS code to a Google Authenticator code or push-based two-factor auth. And where this starts to really become a problem is if you are building more than one app. Because as soon as you're building more than one app, now you're having to recreate multi-factor auth in every native app interface. And that can just add a lot of time to your development, and it just slows things down when you're building that out. There's yet one more problem with handling passwords in applications, which is a lot harder to solve because it's more about teaching users about best practices. We know that as someone who signs up for accounts and creates passwords, we're not supposed to be reusing passwords, right? But a lot of people do, because it's easier than making unique passwords for everything and figuring out some scheme to maintain that. So the problem is that if you have multiple applications where you are logging into things and you're being asked for your password in all of those applications, how do you know the next time you see a pop-up asking for your password that it's really the real service asking for your password and not something trying to steal your password? Ironically, one of the worst examples of this is Apple, where pay attention next time you're using your computer or your phone to how many different times and how many different ways you get asked for your Mac OS password as well as your iCloud password. This is just a screenshots I was able to take very quickly by just going into various screens in my computer. And you can see that each one of these looks different, even though they're the same account. Well, two of them are my Mac password, and two of them are my iCloud password. So if I'm ever presented with one of these dialogues in the future, how do I, as a user, understand that it really is Apple asking for my password and not something trying to steal my password? This is a screenshot from this great blog post that demonstrates this on mobile, where the screenshot on the left is the actual iTunes or iOS pop-up asking for your iTunes password or your iCloud password. They also call it 5 different things. And on the right is a game that this developer built and popped up. The game pops up this dialogue asking for your iTunes password, your Apple ID. Again, these dialogues look exactly the same. So as a user, how are you supposed to know which one is safe to enter your password into? And that's just not something that is easy to communicate to users when you're in the situation of showing password dialogues that look different all the time. And then these are examples of why passwords are a problem for first-party apps, but it gets to be even bigger problem when we're talking about third-party applications. So this used to be a very common pattern on the internet where an app like Yelp would launch and it would go and say, hey, let's see if your friends are already using the app, and it would want to get access to your Google contacts in your email. So to do that, it would ask you for your email address and the password to your email. And then it goes and logs in to your email and downloads your address book, and then it can find your friends. And this, of course, is not safe under any circumstances, but it was very common at the time. Notice that it says, this is from Facebook, right? And notice that it says Facebook will not store your password. Well, as a user, you just kind of have to trust that. There's no way to guarantee that. And the other thing you're trusting is that it's going to only access your contacts, even though you're giving it your Gmail account, and it could access any data in Gmail. So all of these problems are really what are motivating the creation of OAuth. In this third-party app use case, we would like to find a solution that lets third-party apps like Yelp get access to data that they want in order to do whatever function they are promising to the user, while preventing access to other parts of the account that they don't need access to. So that's really the problem statement that OAuth was created to solve, which is how do we let apps access data without sharing passwords? And this applies to both first-party apps as well as third-party apps. In the third-party app use case, obviously it means that the third-party app doesn't ever need to touch the user's password, which is great for security. And in the first-party app use case, it also means we can better integrate multi-factor auth and also avoid having to give users complicated rules about how to identify phishing attacks. So that's kind of the origins of OAuth and how that was originally created. So OAuth, it turns out, is not a single spec. OAuth is actually a collection of several specs. And the way this is set up is these are all kind of, think of them as like building blocks, where they all provide each of these specs provides a specific feature, and you can stack them all up to build a complete system. So this core document, RFC 6749, is the original core OAuth 2 spec. And this defines a few what are called grant types that talk about different ways that an application can get access to data in an API. The thing that is not defined in the core spec is, for example, what that access actually looks like. And in practice, the most common way that access is represented is with what we now know as a bearer token. And a bearer token is the idea that if you are holding on to the token, you can access that data. So think of it as the same way as you would a hotel key card, where you go to the hotel, you check in, they give you this key card, which gives you access to various rooms in the hotel. That key card does not necessarily represent you as a person. It represents that you can access certain resources in the hotel. So that is actually documented in a separate RFC, the idea of a bearer token, where if you are in possession of this token, you can use it. So that RFC talks about various ways to use the token, for example, in an HTTP header or in a form post body or in a query string. So, okay, that's the foundation. And then we get into some of the different recommendations that have popped up over the years around specific kinds of applications. When OAuth was first created, mobile platforms were very, very new, and single-page apps were also very new and hadn't really taken off yet as a normal pattern on the internet. So what that meant was that there were some sort of workarounds, I guess, or things in the core spec that were were there because of the limitations in these early platforms. Primarily, the idea of using what we call the front channel to send the access token to the app. So in the implicit flow, what happens is the OAuth server sends the access token back to the app through the user's browser, and the fact that it's going through the user's browser is makes it rely on the front channel. And I like to think of sending data via the front channel as putting it in an envelope and mailing it to somebody, and then you kind of just have to hope it gets there. The problem is that if you've put it in an envelope and shipped it in the mail, you no longer can actually be sure that it got there or that it wasn't stolen or copied along the way. And similarly, on the receiving end, you can't actually know if it's from who you think it is. So if we're ever using the front channel in OAuth, we have to be able to account for that and compensate for the fact that we lose that visibility on both sides of the transaction. And that is what the Pixie extension is for. So Pixie, yet another RFC, adds in some security features around the use of the front channel to make it actually safe to send data in the front channel. And in practice, this also means that instead of relying on the implicit flow, we can now use the authorization code flow and protect the authorization code's use of the front channel with Pixie. So over the years, we then ended up with another RFC making specific recommendations for mobile apps as well as for browser-based apps. And thankfully, the browser world has evolved over time, and we no longer really have to support things that are lacking a lot of the modern features like IE9 and Safari 5, primarily cross-origin resource sharing, which is a key component to being able to use the authorization code flow. Now that CORS is widely accessible and widely available in browsers, it's not really a problem anymore, which basically means the implicit flow isn't needed. The implicit flow was a workaround for the lack of cross-origin resource sharing support, so it's not really needed anymore. So one of the other documents that's being worked on in the group is the security best current practice, which is a document that is encapsulating all of the best practices of how to do OAuth securely today. And things that it is recommending are not using the implicit flow, not using the password flow, and using Pixie for everything instead, and avoiding use of access tokens in query strings. So by now you're probably thinking, okay, this is a big maze of specs, and how do I know how to do this? Well, that is one of the core efforts that I am working on in the group, which is to consolidate all of this sort of mess of the last 10 years of specs into something that's a lot simpler to read, which is OAuth 2.1. So if you look at the OAuth 2.1 spec, you'll find that it actually describes a much simpler version of all of the past documents. And the goal here is to really consolidate things, capture the best practices. OAuth 2.1 is not meant to be something that's new or adding new features. It's really meant to be a consolidation and simplification of the existing specs and of the best practice today. So the links for that draft, oauth.net/2.1, will give you a link out to all the related documents as well. So that's the current state of the core, sort of what we call the core of OAuth. I also want to talk about some of the in-progress work that is nearing completion or was recently completed, to talk about some of the different ways that work is evolving as well. So there's three I want to call out specifically, three drafts. The first one is JSON Web Token Profile for Access Token, which is now pending its RFC number. It's very, very close to being finalized. There's Depop, which is a proof of possession technique, as well as HTTP signatures, which is also a proof of possession technique, which I'll talk more about what that means in a second. But JSON Web Token Profile for Access Tokens, it's a long name, but basically what this spec is doing is this is saying, if you're going to implement access tokens as a JSON Web Token, then here are things to keep in mind, and here's the best way to do it. Access tokens by no means have to be JSON Web Tokens. You can use, for example, just a random string as an access token, and it will work fine. But if you want to use JSON Web Tokens to provide you all the benefits that those do have, Here's how to do it. And the JSON Web Token access token will contain certain claims with a list of certain ways to validate those claims, and that's what's captured in that spec. Another highly in flux or in progress and topic is this idea of sender constrained access tokens. So what I want to get at here is that there is an underlying problem with bearer tokens, which was actually the reason that it was split out into a new RFC way at the beginning of OAuth, which is that if you can steal one, you can use it. And again, think of the hotel card key example. If you find a hotel key on the floor, you can pick it up and you can try it on a door, and it might work and it might let you in, even though that key card was not issued to you. So the solution to this is to require some sort of authentication of the client instance of the software that's actually using the access token before it can actually use the access token. And the some sort of and the client instance are the things that are being worked out and need to sort of be teased out until there's like a good solution for it. There are several techniques for solving this problem that are documented today and in various states. There's mutual TLS, which is an RFC. There is also a handful of individual drafts. Some of them are adopted by the working group as well. We don't have time to go through all of the details of all of these, but I will say that the top three here are the ones that are the most either mature or I think have the most potential for being the ones that end up being final. Depop and HTTP signatures are similar to each other. Depop is the idea of creating a signature about the request and putting it in an HTTP header. HTTP signatures does as well, but it does it a different way, and they have a couple of different trade-offs. So it is worth looking into the details of these if you're curious. But again, both of these are very much in progress. They're not stable extensions yet. There's a couple of other really fun extensions happening that are adding features, not necessarily just adding security. So for example, rich authorization requests is one that is meant to be able to describe requests that an application is making beyond what you can describe with scopes. So you might have seen screens like this where it says the app is trying to access your contacts. But what if you had a screen like this that said this app is trying to pay this merchant by name this dollar amount from this bank account? Well, you can't describe that in scopes. So instead, what rich authorization requests is doing is providing a framework for describing these kinds of rich authorization requests. Push authorization requests is the idea of reducing reliance on the front channel even further. So in typical OAuth, you will start the OAuth flow in the front channel by sending the user's browser to the OAuth server. Instead, push authorization requests will initiate the flow in the back channel by first having the client go talk to the OAuth server, and it gets back a reference that it can send the user's browser to instead. The idea here is just reduce reliance on the front channel, because the front channel is always possible to attack it in various ways. So this prevents that completely by not putting any of the request data in the front channel. There's another attempt at securing the authorization request using a JSON Web Token. This one is also, it does use the front channel, but it creates the request in a JSON Web Token so that it can be signed and then it can't be tampered with, which is a different solution to the same problem. So that one I believe is farther along than push authorization requests, but I do expect both of these to make their way through the process. And the last thing I want to talk about is future OAuth. You may have heard rumblings of OAuth 3. Is there an OAuth 3? Turns out there is not an OAuth 3, not right now. There have been some efforts to do things in a what could be called OAuth 3 way. There is an effort called Transactional Auth, or OAuth XYZ, which has since been renamed. And that work is now happening in a new working group in the IETF called the Grant Negotiation and Authorization Protocol. This is a new working group. It's not the same as the OAuth working group. It's different people, but there is some overlap between the two groups. And the idea with this group is to continue to evolve the space, evolve what is possible in this kind of world of delegated access or single sign-on, but not relying on the legacy of OAuth of not making it backwards compatible, not worrying about supporting existing stuff. It's more just like, what could we do if we didn't have to have any backwards compatibility and we could just start from scratch and redesign this whole thing. Some of the principles there are back channel first, the idea of the client instance, meaning a particular install of an app on a phone or in a browser, that is a first-class citizen. It's no longer sort of a concept that's kind of shoehorned in. And the asymmetric cryptography or proof of possession techniques are baked into the spec, and they're not necessarily extensions. So that work is also very much in progress. It's very early days, but you can participate in that if you are curious about it. There's all these links are on oauth.net. And with that, I want to leave you with some places to go for further reading, further research on this, so that you can continue your journey through the world of OAuth. If you're curious about looking at the OAuth flows, the authorization code flow, Pixie, OpenID Connect, the Oauth Playground is a great way to try these things out. This will walk you through a simulated flow version of all these flows where you can see the requests and responses in detail so you can try this stuff out and see how it works without writing any code. I also have a video course available. It's at this URL. And this is there's a lot of content in here that goes into a lot of the concepts in OAuth in great detail. And it's about 3.5 hours of video content. I also have a book, oauth2simplified.com. You can also find the cat stickers at that link as well. And the book is also a in-depth guide to the world of OAuth. The book is actually also available online if you just want to read it as a website. You can go to oauth.com and the full contents of the book are available there. And with that, thank you very much. Thanks for having me. I hope you learned something today, and I'm happy to answer a few questions. Looks like we have just enough time for some questions.
Thanks, Aaron. That was really thorough. Can you, could you repeat the URL? It's an easy one to mention, the one for the book, for the training materials.
You'll find everything at oauth2simplified.com. So that links out to the book, as well as the video course is linked down at the bottom as well.
Okay, fantastic. Thanks. I'm afraid we're out of time. There is a couple of questions from Christian Rubach in the main stage. I'm wondering if after you get off this stage, if you could have a look at those chats and respond to him there.
Absolutely, I'd be happy to.
Okay, wonderful. Thanks very much. And I invite you to leave the stage now.
All right.